Right now, there is a clock ticking inside your bones. You didn't start it. Not your parents. Not even humanity, not deliberately. And yet, because of this clock, we know the true age of ancient Egypt. Here's the strange part. To learn that, we had to quite literally set the atmosphere on fire. Sounds insane, doesn't it? Because for thousands of years, humanity thought it knew the past. But in reality, it was only guessing.
The Egyptians wrote everything down. They recorded their kings. They carved time into massive blocks of stone, but they couldn't answer the simplest question of all. When? The pyramids were there, but they didn't come with a manufacturing date. And that was the problem. For centuries, humanity looked in only one place to measure time: the sky, the motion of the sun, the cycles of the moon, the slow dance of the constellations. But here's what no one tells you. All of this is approximate. None of it is precise, especially when it comes to ancient civilizations. Egypt, Mesopotamia, China, they were all quite literally floating in time. We had lists of pharaohs, but those lists were full of contradictions. We knew which events came before others. The order of the pages was clear, but we didn't know which year those pages belonged to. We didn't know where we were in the book. Archaeologists gave this frustrating problem a poetic name: floating chronologies. Archaeology was no longer just about digging. It became a science of comparison. Match Mesopotamia to Egypt. Align Anatolia with the Levant. But science doesn't like uncertainty. Science doesn't say, I think. Science says, this is. And the past could no longer be guessed. It had to be measured. That uncertainty wasn't resolved until the 20th century. And the solution didn't come from archaeologists. It came from somewhere completely unexpected and slightly terrifying. The Manhattan Project. One of the chemists working on the atomic bomb, Willard Libby. Libby took a force capable of destroying the world and used it to measure the path. Right now, above our heads, cosmic rays are constantly striking nitrogen atoms in the atmosphere. This is a neutron bombardment, and from those collisions, a radioactive isotope is created, carbon-14. That isotope combines with oxygen, becomes carbon dioxide. Plants absorb it. Animals eat the plants. We eat the animals. So every living thing breathing right now, you, me, the trees in the forest, is taking this material into its body. As long as an organism is alive, the amount of carbon-14 inside it stays in balance with the atmosphere. Carbon in, carbon out, no clock. But the moment that organism dies, the doors close. New carbon stops entering, and inside an invisible clock begins to tick. Mummy linens, wooden coffins, breadcrumbs sealed inside Pharaoh's tombs. To Libby, these were no longer artifacts. They were timestamps. Carbon-14 decays by half every 5,730 years. That number never changes, ever, like a metronome. And when those measured ages were compared to written history, the result was shocking, almost perfect agreement. For the first time, history stepped out of stories and into numbers. Even as you watch this video, an atomic clock is ticking inside your bones. And for the first time, humanity could measure the past, not with rumors, but with atoms. But if the clock were truly perfect, the story would end here. Because in science, there is always an however. Libby assumed that the amount of carbon in the atmosphere had always been constant. He was wrong. Solar storms, shifts in Earth's magnetic field, massive volcanic eruptions. All of them disturbed the atmosphere and distorted the clock. The clock needed calibration. And the answer wasn't in the stars, it was on Earth. An astronomer cast out of academia, A. Ellicott Douglas, exiled for debunking the myth of canals on Mars. He found the answer in trees. Trees are silent, motionless, but some have been alive for thousands of years. One ring per year. A good year, thick. A bad year, thin. But the real breakthrough was this. Those rings form a unique, unbroken barcode. Dead trees could be matched with living ones, creating calendars stretching thousands of years into the past. Trees weren't measuring time, they were remembering it. And for the first time, carbon-14 clocks were anchored to real time. Estimates collapsed, measurement began. But one problem remained: time itself. Einstein had already shown that time is not absolute.
It depends on speed, on gravity. It can bend. To test this, we built atomic clocks. Cesium-133 atoms, vibrating billions of times to define a single second. We put those clocks on airplanes. Sent them higher, farther from gravity. They sped up. When they returned, they slowed down. Einstein was right. But humanity didn't stop there. In the 1950s and 60s, we detonated nuclear weapons in the atmosphere and physically shattered the planet's carbon balance. Scientists gave this effect a chilling name: the bomb pulse. Einstein said time was relative. We went further. We physically broke time. Today, that nuclear signature can still be read in human bones. Everyone born after 1950 carries it. In teeth. And in the rings of trees. Ancient civilizations are no longer silent. Egypt speaks. Mesopotamia whispers. Because their time is no longer written in fragile stone. It is written in indelible atoms. Time was always there. But to learn how to read it, we first had to step down from our throne in the heavens and then set our own atmosphere on fire.